Okay, everybody, welcome to Mathematics and Molecules, first episode of this series. Section 1.1 for AP Chemistry, covering moles and molar mass. So this is our first problem here. It tells us a 10-gram sample of calcium reacts with 25 grams of chlorine gas to form calcium chloride. Identify the limiting reactant and calculate the mass of calcium chloride produced. So we have our equation, we have calcium, our calcium ion, and we have our two chloride ions, and they're going to react to make calcium chloride. Now, we know we have 10.0 grams of calcium, 25.0 grams of chlorine gas. So now we need to look at it. We say we need to figure out the moles of each of these reactants. So that means we have to divide our 10 grams of calcium by the molar mass of calcium. So we have 10.0 divided by, and then the molar mass of calcium is 40.08. And thinking about this in terms of units for a second. We have grams, and we have, this is an 8, we have grams per mole. So when we cancel out the units, we can cancel out grams on both sides, and we're left with 1 over mole in the denominator, which is the same thing as just mole in the numerator. So that's how you know that you're getting moles from dividing grams by molar mass. And if I plug this into the calculator, this will give us 10.0 divided by 40.08. So we have 0.2495 moles of calcium ions. Now we're going to do so I'm going to go ahead and box this. We're going to go ahead and do the same thing with our chloride ions. We have 25.0 grams of chlorine, and we're going to divide that by the molar mass of chlorine, which is 35.445 grams per mole. And if we go ahead and plug that into the calculator, I'm just going to write that down there. We get, 25 divided by 35.45. Oops, 25 divided by 35.45. We get 0.705 moles of chloride anions. So now we need to figure out which one is the limiting reactant. I'm going to go ahead and move down a little bit. So don't forget our equation we've got there. We're going to go ahead and figure out how many of the calcium ions and the chloride anions make the calcium chloride. So we have, we know for every mole of calcium 2+, we're going to make 1 mole of calcium chloride. So we know that if we have 0.2495 moles of calcium ion, we're going to make 0.2495 moles of calcium chloride. So 0.2495 moles of calcium chloride if we had excess of the chloride anion, right? Because that's assuming all of these moles react. And then the same over here, we have 0.75, but we know that 2 chloride anions make 1 calcium chloride. So actually, if we had 0.705 moles of chloride anion, we would actually have to divide that by 2 to figure out how much calcium chloride we would get, right? And you can think about this with dimensional analysis for a second. So 2 chloride anions, let's do this. 0.705 moles of chloride anions, right? And we know that for every 2 moles of chloride anions, we're going to make 1 mole of calcium chloride. So when we cancel out these, mol cancels out. We have 0.705 divided by 2. So then in this case, where we have the calcium ion in excess, we would have 0.3525 moles of calcium chloride. So then when picking our limiting reactant, we always want to choose the one that makes the least of the products, because that means that that it's the one that's being limited. It's the one that has the least. So in this case, we have the least amount of reacting calcium ions. So our limiting reactant will be our calcium ion, and the mass of calcium chloride produced, it'll be going to go ahead and do 0.2495 moles of calcium chloride. And we're going to go ahead, I'm going to open some space up for myself over here. Chloride times the molar mass, which we said molar mass of calcium is 40.08. Molar mass of 2 chlorides is 35.45, so we do 40.08 plus 2 times 35.45. We get 110.98 grams per mole. And you can see those units cancel out, and we get 0.2495 times 110.98. We get 27 point. And you guys will learn about this later, but sig figs, we have 3 sig figs here and 3 sig figs here. So we're going to do it to 3 sig figs here. Let's just say it's 27.7 grams calcium chloride. Don't forget your units. Okay, our next question here. We've got aluminum reacts with bromine to form aluminum bromide. If 6 moles of aluminum reacts with an excess of bromine, calculate the mass of aluminum bromide. Okay, so we know that Al3 plus Br minus 3Br minus makes AlBr3. That's the reaction it wants you to work with here. We have 6 moles of aluminum, so we have 6 moles of aluminum react with an excess of bromine, so there's a bunch of bromine. Calculate the mass of aluminum bromide. Well, let's think about this ratio. For every 1 mole of, well, let's start with this. We have 6 moles of aluminum, and for every 1 mole of aluminum, we are going to have 1 mole of aluminum bromide. Aluminum bromide. So now just thinking about this ratio, aluminum cancels out and we get the units we desire, which is moles of aluminum bromide. So now let's just do, easy math, we get 6 moles of aluminum bromide. 3. Now I got to calculate the mass of aluminum bromide. So to do this, we need to find the molar mass of 1 aluminum and 3 bromine. So we know the molar mass of aluminum, I'm going to look at a table over here, is 26.98. So 26.98. And then we'll look at the mass of bromine, which is 79.9. But there's 3 of them, so 79.9. We're going to get, let's add that up. Our molar mass is 266.68. And we have 6 moles of it, so 6 times 266.68. Sorry for the messy handwriting. We get 1600. Let's just say 0.1 grams of aluminum bromide, which is a lot of grams. So that is our final answer for this. Okay, our next problem. A compound contains 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. The molar mass of the compound is approximately 180 grams per mole. Identify the empirical and molecular formulas of the compound. So this problem may look pretty daunting at first. I know it was for me when I first started doing these kinds of problems. But it's actually very simple. If you imagine this like we have 100 grams of the compound, we can say that carbon, we have 40 grams of carbon, because it's 40% carbon. We can say hydrogen, we have 6.7 grams of hydrogen. Oh, I don't need the hydrogen right there. And then we can say oxygen, we have 53.3 grams of oxygen. So we're going to go ahead and divide by our molar masses to get the number of moles in this 100 gram sample. So carbon's molar mass 12.01 grams per mole. Hydrogen is 1.01 grams per mole. And then oxygen is let's just do 16.00 grams per mole. So now we can find out how many moles of each we have in this 100 gram sample. So 40 divided by 12.01 is 3.33 moles of carbon. 6.7 divided by 1.01, we're going to imagine it's going to be 6.63 about moles of hydrogen. And then oxygen, we get 53.33, or 3.3 divided by 16, we get 3.33 moles of oxygen. And now we're seeing something a little bit weird. Our moles of carbon and our moles of oxygen are almost the same, and our hydrogen is almost double that. So we're thinking about it, and this gives us a ratio of our moles of carbon to our moles of hydrogen. So if we think about it, we can actually just divide these by the least of this ratio. So what I mean by that is the least of these three numbers right here is 3.33, and we can say 3.33, we divide all of these by 3.33 to get our ratio. And this gives us 1, this gives us 2, and this gives us 1. So now we know that for every one carbon atom in this molecule, there's going to be 2 hydrogens and 1 oxygen. Or for every 2 hydrogen, there's going to be 1 carbon, 1 oxygen, so on. And that's very useful for us to know. And that's really what the definition of the empirical formula is. So knowing this ratio can actually tell us the empirical formula. So there's 1 carbon, 2 hydrogens, 1 oxygen. And that's our base unit for this molecule. Now, if we want to find the molecular formula, because we now have the empirical formula, we have to find the molar mass of this compound to see how many empiricals fit into one molecular formula, basically. So let's find the molar mass of this. So our molar mass of this is 30.03 grams per mole. We know the molar mass of the compound we have is 180 grams, so to figure out how many empiricals we have in a molecular, we do the molar mass of our molecular formula minus divided by the molar mass of our empirical formula, and this is going to get us approximately 6. So now we can say that it's C6H12O6, and this becomes our molecular formula, and that is glucose. All right, and our last problem here, kind of an easy one. Magnesium has 3 naturally occurring isotopes, Mg24, Mg25, and Mg26. The relative abundance of these isotopes are 78.99, 10.00, and 11.01, respectively, and their masses are 23.985, 24.986, 25.982. Calculate the average atomic mass of magnesium. So this one, you don't even actually need much chemistry knowledge to solve. Magnesium 24, magnesium 25, magnesium 26 are all different isotopes of magnesium, which means they have a different number of neutrons in the nucleus. So we have 78.99% of magnesium 24, and magnesium 24 is 23.985 AMU. So we can say there's 23.985 AMU, and then 78.99, there's 78.99% in any given sample of magnesium. So we can multiply this by 0.7899 plus the next, we link our 10 to our magnesium 25, that's 24.986, 24.986 times 0.1, and then plus, last one right here, we do 25.982 times 0.1101. And now we just go ahead and multiply all these, 23.985 times 0.7899. We get 18.94, let's round it 6, plus 24.986 times 0.1. Didn't even need a calculator for that one. 0.4986 plus this one, 25.982 times 0.1101. 2.8606. And now we go ahead and add all of these together. And adding all of that, we get 24.305 grams per mole. Alright, thank you guys so much for watching this video. If you enjoyed it or learned something, please like and subscribe. Share it to your friends who are struggling in your AP chemistry class. And I will catch you next time.